Lesson 57, we're back to scientific notation. We first introduced scientific notation with large numbers, and then we did some operations in scientific notation with large numbers. And then we did introduction of small numbers with scientific notation. Now we're going to do operations with small numbers in scientific notation. So what we're looking at here is 8 numbers all in scientific notation, and 2 of them are being multiplied by one another. 2 factors here, and we're going to get a product. Okay, so the point is that we want to take these numbers that are in scientific notation, multiply them, get an answer that is in scientific notation without ever taking them out of scientific notation. So, and it actually can be a very easy process. So we've already learned how to do this. The same rules apply. Because multiplication is commutative and associative, we can regroup the multiplication like this. Then we can go ahead and do 4 times 2 is 8, and 10 to the 10th times 10 to the negative 6th is 10 to the 4th, because we know that when we multiply numbers at the same base, 10 and 10, that we add their exponents. So there we go. And there's our answer, and it's in scientific notation already. Pretty easy. Not much to do. If you're using a calculator for this, you're thinking about it all wrong. Okay, so on B, again, we can regroup this because multiplication is commutative as well as associative. 1.2 times 3 is 3.6. I don't need a calculator for that. And 10 to the 6th times 10 to the 3rd is 10 to the negative 3rd. So again, our answer is in scientific notation, no calculator necessary. Heck, I wouldn't even expect you to show my initial step on your homework papers. It's really not necessary. We should be able to do that kind of stuff in our heads. And that's what I'm going to do here on C. So we have 1.5 times 3, which is 4.5, and 10 to the 5th times 10 to the negative 2 is 10 to the negative 7. Because negative 5 plus negative 2 is negative 7. And there it is, an answer that is in scientific notation. We never had to take the numbers out of scientific notation. D's got a little added quirk here. 7.5 times 2 is 15. And 10 to the negative 3rd times 10 to the negative 4th is 10 to the negative 7th. Now here's the issue is that 15 times 10 to the negative 7th is not scientific notation. We need to make this 1.5 times 10 to the negative 6th. Okay, these two numbers are equivalent, but the bottom one is in scientific notation. This number that's being multiplied by a power of 10 has to be greater than or equal to 1 and less than 10. So it's got to be greater than or equal to 1 and less than 10. So all we do is divide it by 10. Okay. 15 to 1.5, and then multiply this number by 10, which makes the exponent go up by 1. And it's in scientific notation, and we did not change its value at all. Okay, so that's multiplication. Let's look at division. We did this with large numbers. Now we're just adding some negative exponents in there. So when we say small numbers with scientific notation, we're talking about numbers with negative exponents, numbers that are less than 1. All right, so 7.5 divided by 3 and 10 to the 5th divided by 10 to the negative 2nd is the way we want to look at this. 7.5 divided by 3 is 2.5, and 10 to the 5th divided by 10 to the negative 2nd is 10 to the 7th, because right here when we divide numbers at the same base, 10 and 10, we should be subtracting their exponents. 5 minus negative 2. Not 5 minus 2, 5 minus negative 2, which is like 5 plus 2. Okay. 4.8 divided by 3 is 1.6. Sorry, I'm jumping ahead of myself a little bit. This is how we want to look at this. 4.8 divided by 3 is 1.6, and 10 to the negative 3rd divided by 10 squared is 10 to the negative 5th. And that is in scientific notation. Negative 3 minus 2 is negative 5. 8.1 divided by 3 is 2.7. And 10 to the negative 4th divided by 10 to the negative 7th is 10 to the 3rd. Okay, -4 minus -7. That's like -4 plus 7, which is 3. And then lastly, 1.2 divided by 3 is 0.4. And 10 to the -8 divided by 10 to the -4th is 10 to the -4th. That is not in scientific notation. So what I'm going to do is multiply this 0.4 by 10, and that'll give me 4. Then in turn, I have to divide this 10 to the -4th by 10, which is going to subtract 1 from its exponent. And then it's in scientific notation. Now this number has got it's bigger than 1. It's greater than or equal to 1, and it's less than 10. So if you're going to make this part look bigger, you have to make this part look smaller to balance everything out. That's the really easy way I remember everything. But technically, you're dividing or multiplying this by 10 and then dividing this by 10, so it just all evens out. A dollar bill weighs about 0.001 kilograms. What is the weight of $1 million bills? Express each number in scientific notation and perform the calculation in scientific notation. Okay. So 0.001 kilograms is 1 times 10 to the -3rd kilograms. And $1,000 or $1 million bills is 1 times 10 to the 6th. All right, so let's look at this here. We're going to take the 1 times 10 to the -6th bills, I'm sorry, to the -3rd kilogram, and we're going to multiply that times each of the bills, and that should give us the weight of all the bills. 1 times 10 to the 3rd. 1 times 1 is 1. 10 to the -3rd times 10 to the 6th is 10 to the 3rd. This is kilograms per bills. This is number of bills. The bills cancel out, and you're left with kilograms. Okay, we're all done, and I'll see you soon.